It's a tale as old as time. A new Switch or phone comes out, and within a month, someone's managed a jailbreak. And even if most of them are purely for aesthetic reasons, it doesn't change the fact everyone thinks of it as some kind of magic. Magic that's actually pretty logical to follow. So let's take this phone made by Lemon Incorporated and see how the magic happens. The first step in jailbreaking our Lemon phone is finding an entry point in what's called a chain of trust. Every phone has a chain of trust. Basically, when you turn it on, it doesn't just jump into the full system. Instead, it goes through a sequence of smaller programs, each verifying the next before handing over control. That way, it makes sure nothing malicious has been slipped in. It kicks off with a hardware-based root of trust that activates inside the Lemon phone's processor. Then, it verifies the bootloader's integrity. The bootloader checks the OS. The OS checks the system apps. It's a one-step-at-a-time thing, except if anything doesn't pass the check, the whole thing stops. Jailbreaking focuses on removing built-in software limits on a device like this so you can do more with it, like customize the look, add new features, or install apps the manufacturer didn't approve of. We're not stealing or breaking anything here, we're just unlocking the phone's full potential. And to do that, we have to find ourselves a vulnerability. These are often buried deep in everyday apps or overlooked system functions. In our case, we found a flaw in the Lemon phone's PDF viewer. It wasn't properly checking how files are structured, which made it possible to create a sneaky document that causes what's called a buffer overflow. And while exploits hide in messy code, sometimes it's about crafting clean, delightful interfaces. Speaking of which, today's video is brought to you by Mobbin, the ultimate design inspiration platform for creators like you. Imagine having access to over 500,000 real-world app screens and 80,000 user flows from 1,200 industry-leading apps all at your fingertips. That's Mobbin, and I have a 20% discount for it just for you. Forget sifting through conceptual designs or manually taking screenshots for hours. Mobbin empowers you to find highly relevant design references in seconds. Whether you're benchmarking competitors, researching UI patterns, or staying up to date with the latest trends, Mobbin has you covered. With powerful features like NLP search, visual search, and text in screenshot search, you can find exactly what you need when you need it. And with their Figma plugin, you can export screens directly into your workspace. From freelancers to enterprise teams, Mobbin offers plans to suit every need. Join over 870,000 designers worldwide who are using Mobbin to create great digital experiences faster and smarter. Check out Mobbin today and elevate your design game. Links in the description below. All right, so here's how buffer overflow works. The PDF viewer sets aside 10 bytes of memory to store the document title. If the file has a 15-character title, those extra 5 characters don't just disappear, they overflow into a nearby memory that could hold important data or instructions. And if jailbreakers carefully craft this overflow, they can use it to slip their own code into places it shouldn't be. And once that code is running, it can do all sorts of things. It might disable security checks, open the door for apps from outside the official store, or let the jailbreaker run commands directly. So basically, full admin access. Sometimes it can even tell the system to jump somewhere else in the memory entirely, skipping the usual checks and balances and landing right in unauthorized territory. Now, if that buffer overflow trick doesn't pan out, there are other ways in. One is a downgrade attack. It works by tricking the phone into installing an older version of its operating system that had known bugs. So if Lemon OS version 2.0 is patched, but version 1.0 wasn't, forcing the device back to version 1.0 reopens the attack window. It's like reintroducing a bug that developers thought was long gone. But if that doesn't work, and it's still too secure, jailbreakers might turn to cold boot attacks. If you cut power to the phone and restart it in just the right way, some data in RAM can stick around for a few moments. That includes encryption keys or other sensitive info that could help bypass protections. This works because RAM doesn't instantly forget everything when you shut off power. Then it fades slowly, and hackers use that tiny gap. And when software tricks run out, hardware mods are the next step. They might solder tiny wires onto the circuit board, add a mod chip that intercepts internal messages, or tap into debugging ports like JTAG left exposed by the manufacturer. These are last resort techniques when no software vulnerabilities exist. They require serious precision, a steady hand, and usually a microscope. Let's say one of these methods worked. We're not done yet. That first exploit only gets us part way, and what we need now is deeper system access. Operating systems like Lemon OS are built with privilege levels, or rings, that separate what different types of code are allowed to do. The lower the ring number, the higher the privilege and the more control over the system. User apps like our PDF viewer run in Ring 3, the lowest level. They're isolated from the important parts of the system, so if they misbehave, they can't do serious damage. At the other end is Ring 0, where the kernel lives. This is the core of the OS, with full control over hardware and system functions. So if we really want to take over the Lemon phone, our code needs to run in Ring 0. This means we need to find a kernel-level vulnerability, something inside the OS itself, not just its apps. And let's say we did. On our Lemon phone, there's a buggy device driver that doesn't properly check the inputs it receives from user apps. With the right inputs sent from our compromised PDF viewer, we can trick the kernel into running our code with full system privileges. So when we hijack a piece of code that is allowed to run in Ring 0 and make it run our code instead, that gets us to step 3, high-level access. But there's a catch: it won't last. As soon as the phone restarts, it's gone. So we need to make it stick by modifying the boot process. Otherwise, we'd have to re-jailbreak the entire device every time it powers off. This could mean patching the bootloader, installing a custom bootstrap program that runs before the OS, or rewriting protected system partitions. For example, we could slip in a new startup routine that loads our jailbreak automatically every time the phone boots up, even before the OS starts. This turns a temporary hack into a persistent modification. This is how permanent jailbreak tools, like the old Cydia store, worked. Once installed, they became part of the startup process, appearing every time the phone powered on without any re-jailbreaking needed. Users could customize, theme, or tweak their phones without worrying about losing access after a restart. So by targeting the early stages of the boot process, like tweaking the bootloader, installing a bootstrapper, or modifying system partitions, we can turn our temporary access into something that sticks, even after a restart. From one small bug to full control, the whole system is now in our hands. So that's how jailbreakers jailbreak pretty much everything. And with that, we've fully jailbroken our Lemon phone. We went from one small vulnerability all the way to permanent full control access. Now we've got full control of the Lemon phone. We can customize the interface, install any app, or even run our own operating system tweaks. But this wasn't easy. Device makers build serious protections. Jailbreakers find bugs, manufacturers patch them, and the cycle repeats. With every new generation of hardware, we see stronger defenses. Things like secure enclaves, encrypted storage, measured boots, and anti-downgrade systems. But somehow, jailbreakers keep finding new cracks to break that armor. And sometimes, all it takes is running into something small.